A tire manufacturer is supplying a commonly used model of tire to be installed during manufacturing on a new model of car. The mean number of miles until the tires are worn past the safety standard for tread depth for all other models of vehicles for these tires is 50,550 miles. Since this is a new model of car, they will test 20 sets of tires in order to determine if the wear characteristics of tires on this new model differ from those on all other models. The mean number of miles driven until the tires are worn past the safety standard for tread depth for the sample of 20 sets of tires on the new model is 50,250, with a standard deviation of 450 miles. The tire company will conduct a hypothesis test at a 0.05 level of significance to see if the actual average number of miles driven until the tires are worn past the safety standard for tread depth for the new model of car differs from that for all other models. So the situation is that they have been using these tires on models of cars for a while, and for all of those vehicles, the population mean has been 50,550. Now, they have taken 20 sets, so a sample size of 20, and tested them on the new vehicle and found a sample mean of 50,250. The standard deviation was 450. So the hypothesized situation is that the population mean is 50,550. And the question is, does the mean differ for this new model? Now, different would be greater than or less than. So this will be a two-tailed test. So the question is being asked, does it differ? And that is a key word, because differ means, is it equal to or not equal to? So our null hypothesis will be that the population mean is equal to 50,550, like it has been on all the other vehicles, and the alternative hypothesis will be that the mean is not 50,550. Now, there is an assumption that has to be made here. Since our sample size is not at least 30, we have to assume that the population is normally distributed. Now, the next thing that we need to do is establish some critical values, some critical t values. And it's going to be a t critical value because we do not know the population standard deviation. We know the sample standard deviation. So we can do that using StatCrunch or a table or our TI-84 calculator. Using StatCrunch, we'd click Stat, Calculators, T. We have a sample size of 20, so we'll have 19 degrees of freedom. Our alpha level is 0.05, and it's a two-tailed test, so we will put 975 in this area box here, like we did before, and click Compute, and we find a t-value of 2.093, and if we use our table, again, the third column is where we have the 0.975. We're looking at 19 degrees of freedom, and we find the same thing, 2.093. If we're going to use the TI-84 calculator to find this critical t value, we'll click Second, Variables Distribution, and we'll go here to number 4, Inverse T. And the area, again, this is a two-tailed test. with an alpha of 0.05, so the accumulated area will be 0.975. Our degrees of freedom this time will be 19. And if you are using one of the earlier models that doesn't have you to enter those pieces with a menu that way, and it just takes you straight to this inverse t function with parentheses, your syntax order will be the area, 0.975, and then the number of degrees of freedom, and then close your parentheses and hit enter. And it thinks for a second, and it comes up with the same value, 2.093. So up here we have positive 2.093. Down here we have negative 2.093. And basically what's going to happen then is we're going to calculate a t-test value. And if that t-test value is up here in this rejection region or down here in this rejection region, then we are going to reject that the population mean for the new vehicle is 50,550. The calculation for this t-test value is x bar minus mu over s over the square root of n. So we would have 50,250 minus the hypothesized mean, 50,550, divided by S, 450, and then that is divided by the square root of the sample size, so the square root of 20. And we're going to wind up with minus 2.981. We can find this value using the TI-83 or 84 calculator. We'll do that by clicking Stat, go over to Tests, and this will be a t-test, so we will click 2, and it's going to ask us, are you going to provide me data or statistics? If we have a list that has the data values in it, then we would select data, but we don't. We have the measures already calculated, so we will move the cursor over to Stats and hit Enter. Now it's going to ask us some questions. One of the things that it's going to ask us is, what is the hypothesized mean? And that will be 50,550. And then it's going to ask us, what is the sample mean? And that was 50,250. And then it asks us for the standard deviation for the sample, and that will be 450. And then it will ask us for the sample size, 20, and then it wants to know what is the direction of the hypothesis test or of the alternative hypothesis, and this will be a two-tailed test, so we'll make sure that this entry says not equal to, and then we'll come down and hit calculate. And here we're given some important information. The t-test value is minus 2.981, just like we found when we did the calculation using the formula. We can find this using StatCrunch also. We'll click Stat, T-Stats, one sample with summary. The sample mean was 50,250. The sample standard deviation, 450, the sample size 20, and our hypothesized mean 50,550. Either way, we get the same value. We get this t statistic of minus 2.981. Now that is clearly in this rejection region here. So we would reject the null hypothesis. We would say something about this evidence that we found. We could conclude by saying that sufficient evidence was gathered at the 0.05 level of significance to conclude that the mean number of miles for the new model is different from 50,550. Now, remember that these tests, these hypothesis tests, can be conducted using critical t-values and test values. Or we can use alpha, which this time was 0.05, and the p-value. Going back to our StatCrunch output, we have 0.0077 for p-value. Now it's very important when we enter all of our information into this program that we get the alternative hypothesis right so that the p-value is right. If we don't, then this value could be wrong. So that p-value is 0.0077. And here we find that the p-value is less than alpha, which causes us to draw the same conclusion. Reject the null hypothesis. Anytime the p-value is less than alpha, we reject the null hypothesis.